All right, so I hope you attempted the warm-up on your own. So what we're going to start by doing is we see that it's subtraction, so you're going to turn this to a plus and make that a negative, just so we don't lose that negative. You're now going to distribute to every term there. So we're going to rewrite the first one. So the signs will change in all of those. Now we have to determine our least common denominator. So there's an x by itself in both of those. So we know that something in one of our least common denominators will be x. This denominator has an x plus 1, so we know it will also have an x plus 1. And then we check, is the second fraction, oh, it also has x plus 1, so we're good there. For our restrictions, you set each factor equal to 0 to figure out what it cannot equal, because that makes the denominator 0. So x cannot equal 0, and x cannot equal -1. Now, if they have common denominators, which, okay, they both have the same thing, we can now put them all over the same denominator and combine the like terms. So go ahead, try and combine your like terms. There's nothing else to the third power, so our -4x to the third will be here. To the second power, we have a 6x squared minus 2x squared, so that becomes 4x squared. We don't have any x terms, but we have some constants, so -8 plus 1 is -7. So that is my answer, simplified fully. All right, go ahead and attempt the next one. So pause the video to try and attempt it. All right, so go ahead and let's watch the video and see how far you got. Let's start by putting the 5 over a 1, making this plus sign, or this negative a plus, and applying the negative there, and putting our binomial in parentheses. So if we look here, we have a 1 in this denominator. I can say a 1 here, but it actually won't really change anything. If we look in this denominator, I have an x by itself, so we know we're going to have an x by itself in our least common denominator. And then in this denominator, we had an x minus 9. So 1 times x, that's just x, so our least common denominator will be x times x minus 9. This means that we have restrictions, so we set each factor equal to 0. So x cannot equal 0 because that makes the denominator 0, and x cannot equal 9 because that would make the denominator 0 as well. So now let's go ahead and write it out and get a common denominator. So we have 5 over 1. It's missing our purple, so our x. And it's also missing our x minus 9. All right, now let's write out our second fraction we have, so plus 2, oh, and we should have put that in parentheses, 2x plus 3 over x. So this had our purple, so that means we're missing the x minus 9 in the top, so x minus 9, x minus 9. Now we do our third fraction, -6 over x minus 9. So this had the blue, so we're missing our purple, we're missing just the x. So we're going to multiply top and bottom here by just x. So if we start out, let's just multiply the 5x here, so it becomes 5x times x minus 9, all over x times x minus 9. Now here, we're multiplying two binomials together. When we multiply two binomials together, we're going to need to make and use the area model. So off to the side here, I'll make an area model for us to multiply. So 2x times x, 2x squared. 3 times x is 3x. 2x times negative 9 is negative 18x. And negative 9 times 3 is negative 27. So now in our numerator, we write all of that out. 2x squared plus 3x minus 18x minus 27 all over x times x minus 9. So, okay, in both cases, now both of those fractions have our least common denominator. In our third fraction, we multiply negative 6 with x, and it becomes negative 6x over x times x minus 9. And remember, in the denominator, multiplication order doesn't matter, so I'm just writing them all to match. Now, in this first fraction, we still need to multiply out this 5x. So 5x times x is 5x squared. 5x times negative 9 is negative 45x. In our second fraction, let's go ahead and combine our like terms. So it'll become negative 15x minus 27. And our third fraction can stay as it was simplified. So let's take a look. Did all of them have the same denominator now? And is our numerator in standard form? If the answer is yes, we can now put all of this over one fraction that will have a denominator of x times x minus 9. So it becomes 5x squared minus 45x plus 2x squared minus 15x minus 27 minus 6x. Now we're just going to combine like terms. So 5x squared with 2x squared, negative 45x, negative 15x, and negative 6x. And then notice that negative 27 didn't have any like terms. That's okay. It'll stay as is. So this becomes 7x squared. And then we'll do negative 45 minus 15 minus 6, which gives us negative 66x minus 27. And that is our final answer there. All right, again, if you're following along, put a smiley face next to that so I know. You are going to attempt number 3 on your own, so pause the video to attempt. All right, if you are struggling to start or you want to check your answer, let's go ahead and do so. So our first step is, okay, there's no subtractions that we need to turn into plus negatives. We're going to put all our binomials in parentheses, and we're going to color coordinate our denominator. So x plus 4 is different than x plus 1. So my least common denominator here will be x plus 4 times x plus 1, because they don't have any common multiples. And this means that we will not be allowed to have an x that equals negative 4 or an x that equals negative 1, because they would make the denominator 0. All right, our next step is write out our fractions. So this denominator is missing the x plus 1, so we need to multiply top and bottom by the x plus 1 to get your least common denominator. Now we write out our second fraction, x plus 2 over x plus 1. In this case, our denominator is missing the x plus 4, so we multiply top and bottom by x plus 4. They now have common denominators, so we need to do our multiplying. So if we look here, we have a binomial times a binomial, so we're making an area model off to the side to multiply it. and it'll be x plus 2 times x plus 4. So, and then if we look here, it's a monomial times a binomial, so we can just distribute. It becomes 3x plus 3 over x plus 4 times x plus 1. And our new numerator that we just got from multiplying out is x squared plus 2x plus 4x plus 8. And we ask ourselves, do they have the same denominator? Yes, even though they're in different orders, that doesn't matter. It means the same thing. So we can all put it over 1. And combine our like terms. So after we combine our like terms, we don't have any like terms with the x squared, so it becomes x squared. 3x plus 2x is 5x, and 3 plus 8 is 11. So our final answer is x plus 4, or x squared, plus 5x plus 11 all over our least common denominator of x plus 4 times x plus 1. All right, what you're going to do now is those same steps. You are going to put all your binomials in parentheses, identify your least common denominator. Again, they don't have anything in common. So our least common denominator is going to be x minus 1 times x plus 4, which means our x cannot equal 1 and x cannot equal negative 4 because that would make the denominator 0. Now what you're going to do is you're going to try this part on your own. So write it out and get your answer. You will turn this page into the substitute so we can check to see that you were able to do number 4 and you followed along with your video. I'll see you all tomorrow.